Hello everyone, welcome back to uLearn Education Online channel. In the previous videos, we have seen what is the setup of communication system and also how the communication system is classified based on the signal transmission, which means whether it is an unidirectional communication among the users or a bidirectional communication among the users. That is seen in the previous video. Thereafter, we have seen the concept of modulation and why the modulation is important for the communication system. Okay, now in today's video again we are going to see the classification of communication system based on the modulation. So we know that this modulation is a process of shifting a low frequency to a high frequency signal. Okay, so here the modulation we need a high frequency signal. So from the information source we are going to generate a baseband signal, or we can say that an information signal or a message signal. So that low frequency message signal or a baseband signal is superimposed with a high frequency carrier signal in order to get a high frequency modulated signal. So here the modulation, in simple words I can say that the shifting of a low frequency signal to the high frequency signal without changing any information. So based on the high frequency carrier signal, the modulation process will be done. So depending on the type of a carrier signal, this modulation is divided into two types. One is an analog modulation and second one is a digital modulation. Okay, digital modulation I can say it is a pulse modulation. So in the analog modulation I can say that the carrier is a continuous high frequency signal. So here the carrier signal is a continuous signal, whereas in pulse modulation the carrier signal is a digital signal which is having only zeros and ones. Okay, so depending on the carrier signal, the modulation is divided into two types. One is an analog modulation and second one is a pulse modulation. So depending on the type of modulating method, again this analog modulation is divided into two types. So one is an amplitude modulation and second one is an angle modulation. So here we can say that the modulation is shifting of a low frequency signal to the high frequency signal. Okay, for example, if I consider the carrier signal general equation in terms of cosinusoidal signal. So if I write, then I can write as C of t as AC cos of omega ct plus phi. Okay, so the cosinusoidal signal is having an amplitude AC and a frequency fc. I can represent in terms of angular frequency omega c and a phase value of phi. So depending on these three parameters, these three signal parameters, this analog modulation is again divided. One is depending on the changes in the amplitude of a carrier and depending on the changes in the angle of carrier with respect to message signal or modulating signal. So if the modulation is performed with the change of amplitude of a carrier signal with respect to the amplitude of message signal, we can call it as an amplitude modulation. Okay, that is AM. So that concept is covered in the next videos. So after that we are going to see in this concept again it is second one is dsb-sc and next type is ssb-sc and next one is the VSB. Okay, these three will be studied in this course, and why these three will be generated from this AM we are going to see in the next videos upcoming. Okay, so here angle modulation, again this angle modulation I can write it as an omega ct plus phi according to the equation. So depending on this angle modulation is again divided into two types. One is the frequency modulation FM and second one is the phase modulation PM. Okay, so depending on the range of frequencies that is used, again they are divided into narrow band and wide band. Now let us see pulse modulation. Here again the pulse modulation is divided into two types. One is analog pulse modulation and second one is a digital pulse modulation. So here when it comes under analog pulse modulation, here the message signal should be analog in nature. Whereas in digital pulse modulation, the message signal should be digital in nature, means it contains only zeros and ones. So in this analog pulse modulation, we are going to see the concepts. One is pulse amplitude modulation and second one is a pulse width modulation and third one is a pulse position modulation. Whereas in digital modulation, we are going to see delta modulation, adaptive delta modulation, pulse code modulation and differential pulse code modulation. So these different modulation techniques can be explained in this course. Thank you very much for watching our videos. Keep supporting.